Hello, everyone, and welcome to this new episode of the Threat Briefing podcast. Today, I'm joined by Nikki, one of our talented red teamers, to talk about remote desktop exploitation. Hi, Mickey, and thanks for joining.
Anderson.
So, Mickey, can you start by quickly explain what RDP is?
So RDP, it's a protocol that we often use to access another computer or another server. And basically it allows us to control it as if it were our own PC right in front of us. We can see the screen, move our mouse, open applications, and basically use it like any other PC or server. We can even like transfer files and copy items between the two hosts. And it's also something that has become normal to manage infrastructure. That's why it's so interesting for hackers as well, because it's normal. It doesn't seem suspicious anymore.
Can you tell us a bit more about how APT 29, aka Midnight Blizzard, abuses RDP?
So this whole campaign was tracked under the CERT UA number 11690. Basically, on the 22nd of October in 2024, the Microsoft Threat Intelligence team alerted on Russian threat actor sending an abnormal amount of targeted spear phishing emails. They were really sending over 1,000 emails to targets in over 100 different organizations. This included military organizations, government, academia, just anything that basically matches their usual targets. If you look at the attack, the way it happened, Trend Micro mapped out the observation phase. They saw the registration of domains that they were going to use for this attack vector. They were then sending out phishing emails to their targets, and these phishing emails, they had a pretext where they tried to impersonate Microsoft and AWS. We're really using the concept of zero trust in order to get users to execute an RDP file. So this RDP file is a shortcut to start an RDP connection. And in this RDP file, you can already pre-configure certain options. And one of the options that they pre-configured was to basically map the file system of the user with the RDP host, with RDP server. What this does basically is when you connect to the RDP server, which is controlled by APT 29, would have full access to your file system, meaning that they can also drop malware on your host.
So they are signing the RDP file?
Yeah, they did use a Let's Encrypt certificate to digitally sign the RDP connection file in order to make it seem more trusted. And then they would abuse this connection to deploy malware on the system. So it was not a complex zero-day that we were using. It was just plain RDP connection files. If you look at the data from Trend Micro, we can really see that back in August of 2024 until the campaign, the 20th of October, they were registering a lot of domains, about 10 domains per day. Looking at what kind of targets that they were trying to impersonate, we can see that it was mostly governments, but also a lot of NGOs, military, and even some private sector IT cybersecurity firms. If we look at the domains that they were registering, it was mostly targeting NATO allied countries, Greece, Belgium, Finland, Estonia, and Ukraine.
They started with phishing, right? Can you show us the initial phishing email?
The actual phishing email that they sent looked like this. It might be a bit difficult to understand in Cyrillic, but if we translate it, the pretext is them pretending to cooperate with Microsoft and AWS and abusing the principle of zero trust. So saying that you need to have full compliance with the zero trust architecture. And in order to do that, you have to run this quick check. What was very notable is that they were also using AI in a very original way. In the last part, they stated that if anything was wrong, you don't have to do anything because the Amazon Q Business, which is an actual AI application from Amazon, it will already spot that something went wrong and you don't have to report the error to anyone. So basically they're telling the user like, hey, if anything goes wrong, don't worry, the AI will see it and the AI will take care of it, which makes a lot of sense because a lot of users are getting used to AI in their professional life by using Copilot, by using ChatGPT. So they are getting familiar with the capabilities of AI. And then if you look at the RDP file that was attached to this phishing email, so it would just look like a regular RDP file, and they were using a remote desktop application more specifically. So this wouldn't trigger a full RDP session, not the full screen, but just a small application. If we look at the settings, and you really have to explicitly show the details of the connection, otherwise you would not see this menu. But you can see that your clipboard is being shared, your drives are being shared, anything basically attached to your host is being shared with the target server as well. Furthermore, it was also signed, so you can see on the left and on the bottom right that in one case they tried to impersonate the Ukrainian government, and they had a domain registered uagov.cloud, and it was signed using a Let's Encrypt certificate. And the program that they were trying to run in this instance was the AWS Secure Storage Connection Stability Test. So really leveraging the zero trust concept.
So, okay, they were sending an RDP file. So what's next?
Well, there's an open source project. It's called PyRDP, and it has several capabilities. So first of all, how do you set it up? Basically, PyRDP is located in between you, the client, and the target RDP server. And it will forward the RDP connection that you make to PyRDP to the actual server. And everything that the server will display, it will forward it back to the client. So it will really have this man in the middle position the whole time, giving it several capabilities such as credential sync calling, certificate cloning, file system crawling, clipboard monitoring, and even more. So it's a very powerful position to be in if you're using this PyRDP man in the middle tool. The way that APT 29 was using this was also mapped out by Trend Micro. And basically they were using a lot of anonymization to manage their infrastructure. So Tor, proxies, VPN. And then the actual infrastructure were about 193 proxy servers. So these were the servers used to relay to the actual RDP servers. And they had about 34 rogue RDP backend servers. So, okay, you have a man in the middle position. The user will try to open the file. It will connect to the actual server, and PyRDP will be in the middle of everything. So what are then the actual options? Well, once you have the connection and the RDP server has also access to the client's file system, you can do a variety of attacks. Basically, you could drop a link file. A link file is just a shortcut to another application. And you can also register a keyboard shortcut to trigger certain link files. There are pros and cons to every technique here. So for example, with a link file, it's in a lot of environments non-intrusive. There are a lot of people with a very disorganized desktop. So another extra link file would not really stand out. It's easy to set up. It can blend in. But the problem here is that you would have to wait for the computer to restart in order for the keyboard shortcut to actually register. And then you would have to wait for the user to actually, by accident or maybe not by accident, use the shortcut in order to trigger the link file. So you do have this manual interaction that's required. Another option is to abuse the startup folder. So basically you have a folder on your computer, and every time you start up the computer, it will look in this folder for any applications it needs to run whenever it starts up. So you have very reliable execution here. You don't need any user interaction, but a lot of antivirus or EDR products, they also heavily monitor this folder because they know it will be abused a lot for persistence. Two other options, sideloading and app domain injection. So sideloading is when an application uses a DLL, and you would basically make sure that your DLL gets loaded instead. So when the application starts, it will use your DLL. And this is very interesting to, for example, bypass application whitelisting, because probably the application that uses the DLL is already whitelisted and can run. And the DLL is just a part of this application in that case. It's also very stealthy, but the only con here is that you have to know that which apps they have installed, basically. So let's say you have this perfectly crafted DLL sideloading for Teams, but then they end up using WebEx. That's something you don't want to happen and can be pretty annoying. So the same goes for app domain injection. It's also quite stealthy. In this case, it's the sideloading version in .NET. And you would also basically trick a .NET application into running your DLL. Same pro, it will also bypass application whitelisting. But again, it's quite complex to set up, and you need to already have a bit of an idea which applications they use, so you can craft your domain injection as well. So to have a short demonstration from this campaign, on the left side, you will see a victim machine having the zero trust RDP connection file in an empty startup folder. and some accounts in the downloads folders as well. If you would expand the details, which most users will not do, you could see that a lot of stuff is getting shared. It will initiate a remote desktop connection, and you can see on the right side, which is the PyRDP perspective, that once you get connected, all of your files will be downloaded by PyRDP. If you would have something in your clipboard, you can also see it on the PyRDP side. Your clipboard is also being monitored, and this is also being shared with the PyRDP man in the middle. So I've created a little application that spawns as a distraction, even if you would close everything, because at this point, maybe you're starting to get suspicious. It wouldn't really matter because you would see the malware has already been placed in your startup folder and your file system has been downloaded by PyRDP. So that's how easy it could be. And also you didn't need to enter any credentials because PyRDP also has the credential sinkholing capability. So you don't need to enter any credentials. It will just try to authenticate as you, and PyRDP will replace these with the necessary credentials to connect with the RDP server. So you would automatically get authenticated no matter what you would enter. But in this case, because your host tries to authenticate automatically, it just gets accepted and you get authenticated. So that's also an extra step where users could normally get suspicious that you take away from the initial access vector.
Is this technique new, or have APTs used that for a long time now?
The whole technique is not something really new, because usually when we think about advanced persistent threats, we think about them using very novel techniques, very complicated attack vectors. But this is actually something very simple and something that's already been discussed in the past by, for example, Black Hat information security. Now, of course, there will always be a huge debate in the offensive security space about sharing tradecraft, basically. But I feel like when we think about this attack, you can say probably the blog post enabled the attack. But if we look at how APTs operate, they can be very original on their own. They often come up with very sophisticated attacks. So probably they did look at the blog post of Black Hat information security when preparing for this attack vector. But then again, I think the most important part here is, if you think about it, would you rather have this blog post from Black Hat information security and know that this kind of attack is possible, or maybe an APT figures it out on their own? There's no public post about the attack and you wouldn't even know that this kind of attack is possible. So I'm still a very big fan of sharing tradecraft just because it can create this kind of awareness.
How can we detect and prevent RDP exploits?
So you could actually block RDP files on the mail gateway. This isn't done by default. If you would look at a lot of common email gateways, you would see that they have a list of commonly blocked file extensions, such as .exe or maybe even .zip or .iso. But .rdp is actually not being blocked by default on any of these email gateway products. You can also use a GPO to, for example, block the ability for users to run .rdp file. Let's say your users generally do not use any .rdp files. You can just block this file extension for them. You can also use the firewall, to the native Windows host firewall, to block the RDP process, so mstsc.exe, to make any communication to public IP addresses. Because of course, the target RDP server is located on probably Azure or AWS. So you could just block the connection to any public IPs and still allow RDP connections internally in your network. And then also just use a GPO and not allow users to redirect any of their computer resources. So prevent clipboard sharing, prevent file system sharing whenever they would start an RDP session. Of course, MFA will still be a very important one to implement, just because let's say it didn't implement previous actions and it would still occur and they would have the credentials of a user, maybe from their clipboard or maybe from something that the exfiltrated from the file system. You do want the MFA to be in place so that they try to authenticate after the exploit, they wouldn't be able to successfully use credentials. There's also a KQL query to hunt for any email attachments with RDP files. But even if you find something, it could also be IT sharing internal connection profiles. So it's not because you find something that it's necessarily malicious. So we know how to prevent, we know how to hunt for it, but there's also a few very interesting detection opportunities. Here's an example from the vector console where I was executing the attack. And basically what it alerted on was it was a new connection to a domain that I usually do not access. Normally I don't send any data to this domain, and suddenly I sent quite a lot of data to this domain. So I probably even sent more data than I received from the domain. So this is very suspicious. The fact that you connect to a new domain and start sending data to it, or at least more data than you receive, can be flagged as quite suspicious. Another opportunity is the JA3 or the JA4 fingerprints. So basically, when you would normally connect to an RDP server, you would have TLS negotiation because all of your traffic is encrypted. Now, JA3 and JA4, they basically fingerprint these TLS connections. And the thing is, if you would have SSL connection with or TLS connection with an RDP server, it uses the Windows TLS configuration. Whereas with PyRDP, you basically have a TLS configuration from the Python SSL module. So these look differently. As you fingerprint them, they look very different. You can see here on the left, the PyRDP version, and on the right, the regular RDP server, and you can see that the fingerprints are not the same. So this is also a very interesting technique to use to basically detect that you're not connecting to a native Windows machine. And then also something interesting, the keyboard layout. If you would decrypt RDP traffic, you would be able to find a packet with the keyboard layout. So it's highlighted here in the image, where basically it has this code for what kind of keyboard you're using. Now, when you're sending campaign as masses as APT29 has done, it's very difficult to get the keyboard right for everyone. So let's say I regularly use the Belgian BE keyboard layout, and suddenly I would connect to a server and it would be set to a French layout or a Russian layout or anything else. It could also serve as a detection opportunity.
Thank you very much, Mickey, for your valuable insights. That's a wrap for this episode. If you want to hear more insights from Mickey and from our team, please feel free to subscribe to this podcast channel. Also, if you'd like us to talk about a specific topic, do not hesitate to comment on this video. Thank you and see you soon.